So let's go ahead here and learn how to use Binomial PDF and Binomial CDF on our calculator. We're going to compute some binomial probabilities here. So we are going to take n as our total number of trials, and probability of success is 0.4. And we're going to calculate the probability of number of successes is 2. So 2 successes out of 10. So if you got your calculator, get that out. Work along with me. So instead of doing the formula from the previous example, what we're going to do is we're going to use Binomial PDF. That gives an individual value. So that's under the second, and then you hit Variables menu. So second vars. And then you got to scroll down past the end of the screen till you get to Binomial PDF, the first one, which is A. Press Enter, and it asks you how many trials. That's N, which is 10. So let's put a 10 in there. Enter. P, the probability of success, they gave us as 0.4. 0.4, enter. And then the X value, we're interested in X equal 2. 2 successes out of 10. So 2, enter, enter, and enter. And again, if it doesn't give you the menu, if it pops it up, just separate those with commas. So that's 0.1209. So this is Binom PDF, and then it's 10, comma, 0.4, comma 2, and that was 0.1209. Usually do these to 4 decimal places. Okay, so that's for individual values. So try doing the probability of 5 successes with Binomial PDF. So you're going to change your 2 to a 5. Try that and see what you get. So pause the video for a second and try that one. So if we do second variables and go down to choice A, and it keeps the values you had before, just come down and change that 2 to a 5. Enter, enter one more time, 2007 rounded. So you get 0.2007. Woohoo! All right, what about X is no more than 5? So it's not more than 5. Well, that's the same thing as saying less than equal. So if we write this in symbols, this is the probability that X is less than or equal to 5. Because it's not more, so it's not greater than, so it's less than equal. Well, less than equal probabilities, they're given by Binomial CDF, which is option B. So this one we're going to do Binomial CDF. It's still under that second variables menu. And we still keep the 10. It's trials. And the 0.4. And then we want less than equal 5, so we put the ending value in there, 5. So let's compute that real quick. So I'm going to clear this out. I'm going to go to second variables, come down to choice B, Binomial CDF, press enter. Trials were 10. P is 0.4, and then less than equal 5. Paste that in. Make sure you do CDF, not PDF. 0.8338. So now Binomial CDF only does less than equal probabilities. So you got to be a little bit careful. So here we want probability X is greater than 3. So this is probability X is greater than 3. Well, the numbers go from, it's n equal 10, so your numbers go from 0 to 10 here. Those are your X values. Okay, we want the probability that x is strictly less than 3. So that would be 0, 1, or 2. But we don't want to do 0, 1, and 2 separately. And we don't want to do, I'm sorry, I wrote less than 3. It should be greater than 3. We want strictly greater than 3. So that would be 4, 5, 6, 7, 8, 9, 10. So we don't want to do all these separately with PDF. What we want to do is we want to use the opposite probability. So to get the probability that x is greater than 3, you can take 100% or 1 and subtract the probability that x is less than or equal to 3. Because that's the opposite probability. So remember the complement rule? To get the probability of the complement or the opposite, you subtract from 1. Well, this one we can do with binomial CDF. So this is going to be 1 minus binomial CDF. And then that's going to be 10 trials. P is 0.4, and it's less than or equal to 3. Okay, and we can enter it in just like that. And let's go ahead and do that. So let's see. We're going to do 1 minus, and then second variables. And then we're going to go down to binomial CDF. Oops, right there. And then we've got our 10, we've got our 0.4. We're going to change our x to 3. Press enter, enter again, enter one more time. So 0.6177. Just have to remember that the binomial CDF is always giving a less than or equal probability. So any question that you got here, you got to write it in terms of less than equal. And then the last one is a between. Probability x is between 2 and 7. Okay, so strictly between 2 and 7. So we've got 0, 1, 2, 3, 4, 5, 6, 7. If we're strictly between 2 and 7, that would be 3, 4, 5, and 6. Those are the values that we want. Well, we have to decide how to get 3, 4, 5, and 6 from less than equal. So what you could do is you could do, well, less than or equal to 6, and then subtract off 0, 1, and 2. So less than or equal to 2, and that'll leave you with 3, 4, 5, 6. So less than equals 6, that's binomial CDF up to 6. So this is going to be binomial CDF 10, comma, 0.4, comma, 6. So that gives the probability of 0 all the way up to 6. And then we subtract off 0 up to 2. So it's going to be binomial CDF and then 10, comma, 0.4, comma, 2. And you can enter it just like that. And oh, by the way, when you do your exams for me, this is what you're going to enter for work. You won't have to enter work for the homework because most of it is multiple choice, fill in the blank. But for exams, definitely. So let's compute this. So let's clear this out. We're going to go to second variables and come down to binomial CDF. Enter. N and P stay the same. Change that to a 6. Enter. Enter. Pasted it in there. Minus. And then do second variables again. Come down to CDF. Binomial CDF. Enter. And you got to go down and change that 6 to a 2. And enter. Paste it, and then enter. Now it subtracted those two, 7779. So this is 0.7779. So that's saying about 78% chance that we're going to have strictly between 2 and 7 successes out of 10. About 62% chance approximately that we're going to have greater than 3 successes out of 10. And about 83% chance that we're going to have at most 5 successes, less than or equal 5 successes. Okay, so that gives you some practice with binomial PDF and binomial CDF. why don't you try in Canvas here, homework 5.3, problem number 5. So it'll be some problems like this, just using the calculator with Binomial CDF and Binomial PDF.